down to 90. It's going to take its time. Oh, it's on its way to 80. And let that go. Looks like it's going to take a little while to get down to 60, so let's go look at the GCMS spec again. Detector is saturated. Our inset counter warning. The usual error messages. And this time it looks like we have something. Now that could well be a carryover from the previous run, coming off between 2.5 and 5 minutes. There was nothing in there on the last run, but it could well be that it just took a little longer to come off. So that is very likely. We can take a look at it. I'm going to take a snapshot. That'll open up an extra copy of GCMS post run. And so we have that nice peak there. I can integrate it. I have to change these parameters here, get rid of that integrator off command. So it will integrate. I'm going to set that to 1,000,000. It's picking that peak up nicely. And we're looking at only as high as 300. It looks like we got a peak at 261 and we're saturating our detector at 233. Significant peak at 262 as well. So I don't know what that is. I could certainly do a similarity search on it. My guess is that compound's not in there. 1,2H naphthalene-enone, 3,4-dihydro-2-phenyl methylene. So that is at least, I mean, that compound has a molecular weight of 234, so this isn't it. But it is a naphthalene-enone, which means it's a aromatic ring, and it's got a methylene group, phenylmethylene group in there, which our compound should have. So it's got some of the structural features. So as I say, I think that compound is likely to be, I'm not going to save that, the carryover from the previous run. So I'm hoping we'll see another peak out here from this run. It's likely to be the same compound. Since I'm holding it at that high temperature for much longer, it should come out faster. peak on scale. Move the baseline so I can see it better. If it's the same compound, we would expect to see a peak about the same height. And that's what we're seeing here. So chances are good that this peak here around 8.5 minutes is the same as that peak there at 3.5 minutes. But this one was from round 1, and this one is from round 2. And we could confirm that by running it again, and then that peak should go away. So it looks like this method is suitable for at least this aldol condensation product. Whether it's suitable for the other aldol condensation products is a matter to be discovered during the course of lab this semester. So I'm happy with that run. Let's go back and check the melting point apparatus. And we're down very close to 60. Where I want it to be. So I'm going to stick that guy in that center unit. Confirm that it's there and it's not melting. And I'm going to crank this back up to about 3.6 and watch that temperature rise again. And this time we'll watch it pretty carefully so we'll not miss the melting point. I'm actually going to take the camera off my head so that I can point it more accurately at where I think it needs to be pointing. In theory, you are now watching the compound through the magnifying glass. I've got that lined up nicely. And then we can look at the thermometer and you can see we're at about 66. And it hasn't melted yet. Of course, I need to occasionally look at it myself to see what's going on in there. I can't hold the camera there and my eye at the same time. Melting point is not the best technique to be doing remotely. So we're up around 70. And it hasn't melted. Hasn't melted at 78. And it looks like it's starting to shrink a bit. And I see a little bit of liquid. So we are at 79 degrees. And I'm going to leave the camera pointing at it and just read off the thermometer as it goes up. So we're at 79.5. Now we're at 80. Now we're at 81.5. Now we're at 81. Now we're at 81.5. Now we're at 82. And it has obviously fully melted. So hopefully you were seeing that as it was happening and you we're able to determine exactly what temperature it melted at. So clearly melted sample at this point. So it was a low melting one. And in a sense, maybe we got lucky. Stick that back on my head. We'll turn this guy off. I do have other melting points to take at some point, so we'll leave that. Instrument there. We don't need this compound anymore. So we can throw that in the solid waste. I could put it back, but I've got so much material I don't need it. And then I'm just going to rinse that. Just a little bit of acetone to get that off the watch glass. Since I know the compound is acetone soluble and probably not particularly water soluble. I'll also rinse my spatula. So we've got a good melting point. We have some GCMS spec data. We have an IR, and we're just waiting for the NMR to be the final piece of information we need in order to determine what starting ketone and benzaldehyde we had for that. Let's go see if that mass spec run is done. Should be done. Oh, look at that. Support assist for home PCs. Yeah, I don't care. So what we want to do is go back to sample login and change this to round 3 and 57B-4. And we're just going to run this again just to confirm, saving the current method file, sure, why not, just to confirm that this peak came from round 1 and wasn't real, which is almost certainly the case. So it's setting the instrument parameters, and then once it finishes that, we can go to post run and open up that file. There it is. Now post run. And the Aldol product round 2. Oops, not the right file. I'm not doing the Aldol lab. I'm in the Aldol lab today. Aldol condensation round 2 is the one we want to look at. It's only integrating this peak, so I'm going to go and change that so that it'll integrate both of them by getting rid of the integrator off at time 0. It's fine to leave the integrator on, but I don't actually need any of those. Get rid of those. So now I've got it to integrate both peaks. You can see 261 and 233, and it's identical. Almost certainly what we're looking at is this was the carryover from round 1 that was still in the column because it hadn't come off yet, and this is the real retention time. So I'm going to save that data file. And then I want to put this into a report form. And we will open that same format file at morpholine solids. Yeah, that's probably a good one. And drag Aldol product round 2 in there. But I do want to see the whole chromatogram because I want to see that other retention time. So I'm going to change those properties so that I'm actually seeing not just from 5 to 10, but all the way from 2 to 9. So I'm seeing that peak there. I guess I don't need to start at 2, I can start at 3. So I got those peaks. There's another peak with a retention time of 1.446 that's showing up. That's in the solvent cup time, so I'm not sure why we're even seeing that. So at 7.402, we've got this peak here. The base peak is different for these two, but that may be just because of the breadth. That's a broader peak. The peak at 1.4 is solvent, and it's clearly nothing we're interested in. So we don't need that. So it's only showing that first peak, which means I need to add a page.